Okay, 8.5, special factors. Let's start with our warm-up here. It says, determine whether the following are perfect squares. Okay, well, what is a perfect square, Miss Roman? I don't remember. Perfect square, remember, is any number times itself will give you that number. So 4. 4 is a perfect square. Because if I take the square root of 4, I get back to 2. Again, we can do 3 times 3, which is 9. 4 times 4, 16. These are all perfect squares. 5 times 5 is 25. 25 is a perfect square. 6 times 6, 36. That's a perfect square. So x times x would equal x squared. So that is a perfect square as well. Let's take a look at some of these problems. Is 64 a perfect square? Well, yes, because we know that 8 times 8 is 64. Now, if I take the square root of 64, I get back to 8. That's perfect. What if I take the square root of 36? What do we get? 6. So that's a yes, because we get a perfect number, and we know 6 times 6 is 36. What about 45? If I take the square root of that, do I get a whole number? No. So that means there's no number times itself that can give you 45. What about x squared? Well, we know over here, x times x is x squared, so yes, because we know x times x is x squared. What about this one? We have it to the 8th power. This is kind of hard to figure out. Well, there's a trick, because we can't put this in our calculator. If it has an even exponent, it is a perfect square. And all we're going to do here is take half of it. That's going to give you x to the 4th, so this is a yes. Because we have x to the 4th. Now look at here. Is this a perfect square, the 4? Yes. Is this an even exponent? Yes. So again, the square root of 4 is 2, and I'm going to get x to the 3rd because we're taking half of it. What about number 7? No, because it has an odd exponent, correct. So that this is not a perfect square. It needs to have an even. Okay, look at number 8. This is even. Cool. 49. We take the square root of that? Yeah, it's 7. So we're going to have 7p to the 5th because we're taking half. All right, good. So that's how we're going to start this off. We're going to be dealing with perfect squares a lot in this section. So this is a good review. If you wanted to write that down, that would be a good idea. Let's move ahead. To determine whether each trinomial is a perfect square. If so, factor. If not, explain. Alright, so what we want to do here is we want to check out the trinomials. We want to look at the front number and the back number to see if they are perfect squares. Now, is 9 a perfect square and is x squared? Yes, because we know 3x times 3x will give us 9x squared. What's the square root of 64? 8? So 8 times 8. So now these are perfect squares. Okay, so now that we know that they're perfect squares, we can factor. We just got to check one thing. We're going to take one of these and one of these. And what we're going to do is we're going to multiply them. 3x times 8. And the rule is if you multiply them and double them, they should equal this middle term right here. Okay, so let's check it out. 3 times 8 is 24. So I got 2 times 24. Don't forget the x in there. Oh my goodness, that's 48x. Does that equal the middle term? Does it? No, it does not. This is not 48. So when this happens, we can't factor it. So this is not factorable. Okay, good. Let's go to number 2. And let's look at the first term and the second term here. Or I'm sorry, the first term and the last term. Are these perfect squares? Yes. We got 9x times 9x is 81x squared. And we know that the square root of 25 is 5 times 5. Okay, so now we're going to check to make sure it adds up to this middle term here of 90 by taking one of those, 9x's, times 5, and we're going to double it. That's going to give us 45x times 2. What's 45x times 2? What's 45 times 2? 90x. Does that match up? Yes. So we're going to be able to factor this one. This one's a good one. So what we want to do is we want to start by making our two binomials. We know that when we have a trinomial, we're going to go down to two binomials. And what they're both going to start with is our first term, the square root of that first term, which is 9x. We know that 9x times 9x is 81, x squared. And what they're both going to end with is a 5, because we know 5 times 5 is 25. Now, since both of these are plus signs here, they will both be plus signs in here. And we are done. We've just factored that first trinomial. Let's go to number 3. Is this a perfect square? Yep. Is this? Oh, no, it's not. 14 is not a perfect. We know 7 times 2 is 14, but we needed a number times itself. So that is not a perfect square. They both need to be. We can't factor this, but we can do a little bit of work. Can we find the greatest common factor of all 3 of those and simplify it? What is it? What's the greatest common factor of those 3? What number can go into those 3? A 2? Let's do it. Pull out a 2. It's 36 divided by 2. 18, x squared, cool. Minus 10 divided by 2, 5x, plus, what's 14 divided by 2? 7. Excellent. That's as far as you can go. So you would need to factor that out. All right, let's go to number 4. Is this a perfect square? Yes. X times x. Is this a perfect square? Yes. 2 times 2. Okay, let's take that and let's see if it adds up to the middle term. 2 times x. Right? We took 2 times x, and we're going to double it. It's going to give us 4x. Does that add up to the middle term? Yes. So we go right in our 2 binomials. What do they both start with? Looks like an x. What do they both end with? A 2. And they're both plus signs here, so we're going to put plus signs in here. And we are done. Excellent. Let's go to number 5. Is this a perfect square? Yep. Is this? Yes. So we got x times x, 7 times 7. All right, so let's think about it. 7 times x, 7x. We're going to double it. What do we get? 14x. Cool, that adds up to the middle term. So then we go to our 2 binomials. What do they both start with? An x. What do they both end with? A 7. Now I've got a minus sign in the middle here. When that happens, that means that these 2 are going to have to be negative. Double check. What's negative 7 times negative 7? Positive 49. What's negative 7 plus negative 7? Negative 14. Excellent. So this is your answer. And that's an x right there. Getting a little sloppy. All right, number 6. Let's check this one out. We've got 9x squared and 4. Are they perfect squares? Yep. 3x times 3x. 2 times 2. All right, let's check them. 3x times 2 and square it. Right? 3x times 2. I'm sorry, and double it. We'll get, we get 12x. Does that add up to the middle term? No, non-factorable. We stop. And they do not have a greatest common factor, so we can't go any further. All right, so that's the shortcut with perfect square trinomials. Okay, sometimes it can work, sometimes it can't, as you can see. We only got, 1, 2, 3 of them to work. 2 non-factorable and 1 we had to look for the greatest common factor. Cool stuff. Now here's another example of whether or not you have to factor. It says, determine whether each binomial is a difference of 2 squares. 2 squares. Difference means subtraction, so notice they're all subtraction problems. And 2 squares, they both at the end and start with a perfect square. If not, we find the greatest common factor and go. So let's look at number 1. Is this a perfect square? Why not? You're right. You see the 3 here. 3 is not a perfect square. This is a prime number. So when that happens, we know they don't have a perfect square in the front, so they can't have it. However, do they have a greatest common factor? Yes, it's 3. They both share a 3 in common. So we can pull a 3 out, and we can see that we need a p squared minus, what's 9 divided by 3? 3, and we need q to the 4th. So there's nothing we can do but factor out the greatest common factor. Okay, if nothing works out, find the GCF. Okay. All right, let's go to number 2. Is this a perfect square? Yes. Is this? Yes. What's the square root here? 10. So 10x times 10x. 10 times 10 is 100. X times x is x squared. And we can do here, we got 2y times 2y. Cool. Let's go down to our two binomials. What do they both start with? Excellent. Now you notice here that we do not have to check for a middle term because there is no middle term. So what do you think makes that possible? Well, we don't know what the signs are going to be. I'm going to tell you right now that you're always going to have one positive and one negative sign. One plus and one negative. That's the cool thing about the difference of two squares. One will be positive and one will be negative every time. So let's go to number 3. Is this a perfect square? Yes. Is this a perfect square? Yes. They both have even exponents. That's awesome. So we know this is going to be x squared times x squared. Remember, all we're doing is taking half. Look here. We've got square root of 25 is 5. Y to the third, we just take half. Okay, so we know what it's going to start with, and we know what it's going to end with. Go to your two binomials. Start with that x squared. What are they both going to end with? 5y to the third. 5y to the third. What's the signs? That's right, one positive, one negative. One plus, one minus. And there's your answer. Cool. Difference of squares are awesome. Number 4. Is 1 a perfect square? Yeah, because 1 times 1 is 1. What about 4x squared? Yep, 2x times 2x. All right, let's make our binomials. Both starting with 1, and they're ending with 2x's. 2x here and a 2x here. What's the sign in between? Yep, 1 plus 1 minus, and that is your answer. Brilliant. Now, if I'm going too fast, remember, you can always pause the video to write this stuff down. Let's look at number 5. You should probably pause it now and do this one on your own. Now let's take a look. Perfect square, even, even. Let's do it. P to the 4th, right? Times p to the 4th will give you p to the 8th. And square root of 49 is 7. Q to the 3rd. Remember, you're just taking half. So we take that, and we're going to use that to make our two binomials. P to the 4th first. What are they going to end with? 7q to the 3rd. What's the sign in the middle? 1 plus 1 minus. Excellent. You guys are doing great. Let's look at number 6, last one. 16 a perfect square? Yes. Is 4y to the 5th a perfect square? No. We have an odd exponent here. So we can't do that. But we could always look for our greatest common factor. Do they share anything in common? 16 and 4 have something in common. What do they share? A 4. So let's pull out a 4. 16 divided by 4 is 4x squared minus 4 divided by 4 is 1. Y to the 5th. Excellent. Now, do we need the 1 there? No, we don't need the 1. But if we want to put it there, can we put it there, Miss Roman? Yes. That's as far as we can go. All right, so that's factoring perfect square trinomials and doing the difference of two squares here. Hopefully you got a good gist of it and you feel more comfortable to do your homework tonight. Your homework is going to be on page 562, and you're going to do numbers 1 through 20. I recommend working with a partner. Double check your answer. Now remember, the odds are in the back of the book, so you can always check your work. All right, I'll see you guys tomorrow. We can go over any questions that you have.